Okay, so today we're going to talk about debugging. And basically, virtually nothing ever works the first try right away. So you really want to know how to debug. And I'm going to see if I can get myself to show up because this is... Okay, let me pin myself there. Whoops. Swap that. All right. Hopefully that's going to record better now. Okay, because nothing ever works the first time or almost never works, there are going to be bugs. So accept it, and you want to get good at debugging. Debugging and testing take 50% or more of software development time. Same thing for hardware. There's no getting away from this, so you want to become good at this. So any complicated system, you're going to spend a lot of time debugging. So computer chip design, making your car work, figuring out why communication networks work or don't work well. When TELUS or Bell or Rogers are rolling out new communication systems, they actually have engineers who go out and test how good is the coverage, what's going on, and they have to debug it and modify the antenna layout and so on. So it's software in some ways, actually, even though it's maybe frustrating to debug sometimes, actually easier than debugging systems where you have antennas, software, hardware all working together. So you want to develop these skills. Okay, and it is a learned skill. You will get better at it. I've gotten much, much better at debugging through my career. I debug issues that would have just utterly baffled me when I first started. So you're going to get practice in debugging, and think of it that way. Don't think of it as I wrote this code and I wish it just worked. You're getting practice debugging because you got to get good at it. Now, sometimes systems are complicated, so debugging can be challenging, but the system isn't magic. It does follow certain rules of behavior. So if you can figure them out, you can figure out how to debug them. And it's a very important skill. It's one of the questions that I tend to ask potential grad students is, tell me about a difficult debugging problem that you solved, because I want to see that they can debug. And I actually asked this question when I was interviewing people for in industry as well at Altera. I want to see that they know how to debug, they've tried to debug things, they get into it. And
You
when
asked
you
me this
find those
question as
difficult
well.
bugs, it's very rewarding. Sorry, go ahead, Abid.
You asked me this question as well when you were interviewing me.
It is one of my favorite questions. You must have had a good answer. So, there's one of my former PhD students, Henry Wong, who's now at Intel designing on their next generation processor design tech team, like had the most amazing debugging story I've ever seen when he was an intern actually at Altera, and based on this one debugging, we basically decided to hire him, make him a full-time offer immediately. He debugged an issue that Nortel was having, and Nortel at the time had become a very strange company because they're under some financial distress, but they were still a really big company. They were running our FPGA CAD tools on servers they didn't own, and the tools were crashing sometimes, and we could not figure it out. And Henry basically went in and added code so that he was able, through this huge CAD system, to diagnose that there was actually a memory problem on the servers they were running on. So it was actually a hardware problem, not a software problem. He was able to figure out what it was and tell them how to patch the firmware on those servers so that it would work. So I was impressed. My bosses were impressed because this was actually a big enough issue that it was making it up, like all the way to the CEO's agenda. And Nortel was really impressed. So that was a very challenging debugging case, but really good debugging gets noticed. Okay, so what are we going to talk about today? So a systematic approach to debugging. We're going to talk about three models to just kind of help you think about debugging: the infection model, the wolf fence algorithm, and the detective method. Do a debugging demo on milestone 1. How do you debug this? And then finally, if time permits, a team debugging activity. Okay, so first model of debugging is the infection model. So software systems are causal, as are most systems, meaning that inputs affect outputs. The state progresses in time. Okay, so you can use this to note that a faulty operation causes an infection. It makes some of your program state incorrect. The infection gradually can spread through the program state, and eventually it causes an observable failure. So you might crash, you might print the wrong value, But that might not be the root cause. Basically, the bug might have occurred earlier, and it's only made it to be observable later. So like COVID, you're asymptomatic for a while, and eventually the symptoms show up. But it doesn't mean that was when you were exposed. Okay, so we have a program. Its state is okay, but at some point we hit a bug, and now our state is infected. We've got some of our state is wrong. And as the program proceeds, that infected state can spread. More and more of the program state can be wrong because we're using the bad state to compute other state. And eventually something observable happens. A crash, we output something wrong. But that's not the root cause. The root cause was way back here. So we have to figure out how to backtrack. That's one way to just think about what we're trying to do, trying to backtrack from what we observed to what caused it. Second algorithm that we can use is what's called the wolf fence algorithm. So how do we find a wolf in Alaska? Alaska's a big place. It could be a lot of area to search for a wolf. And if all we can do is listen for the wolf and figure out if it's on one side or another of a fence, we can still find it. Okay, so this would be an expensive procedure, but let's say we can draw a fence down the middle of Alaska. So we divide it horizontally, we listen for a wolf, and we figure out it's in the left half. So we can eliminate the whole right half side of Alaska. Build another fence, listen for the wolf again, figure out it's in the top. So we can eliminate the whole bottom part. Keep doing this, keep listening, keep eliminating spots where the wolf might not be, and eventually we get down to a pretty small spot, and we've either found the bug or we've got a very small area to search in. We can do the same thing in code. We don't have to, and this is actually really important in big programs. We don't have to understand the whole program. We can just run tests to figure out, is the bug in this part or this part, and gradually refine down our view of where the bug occurred to a very small part of the program. And then we go and look at that part in detail. And yeah, in a large program, just like a large state, this is feasible. But searching through, reading the whole program and trying to figure out what's going on is really not feasible. We need to divide down the problem first. Okay, so identifying the root cause of a bug is tricky. We have and this is like how we can behave like a detective. We have many variables in our program, and as time proceeds, those variables can change in complicated ways. So we've observed a failure here, and we need to figure out why did we get that problem. So we need to be systematic about this. So we make decisions of what's going to help us localize what might have caused this, and what is easy to do. And you kind of balance those two things to decide, what do I try next? We can use the fact that the program is causal, meaning this observed failure must have come from previous states. So we know that the problem occurred either right here or maybe earlier. And we can use this wolf fence idea to try to eliminate parts of the program. Okay, so we might use the wolf fence algorithm to basically let's check all of our state at this point in time. And we can check and find that it's all good. Okay, so we've done a wolf fence. We've said the bug does not occur before this point. Okay, we can eliminate all those that part of the program. We could do another wolf fence where we check, is there any problem with the variables on the right? And if there isn't, if those are actually correct in the final analysis down here, we can eliminate those as part of our problem. And we're gradually dividing down the space and getting to a smaller potential set of bugs. We can then look at, okay, we can switch now from wolf fence to the fact that programs are causal, that their outputs, well, their next state depends on their prior state. So we can look at this variable, which is incorrect. We know that. It prints out a failure. And we can say, well, what does it depend on? Maybe it depends on two variables that were computed earlier. So we can go look at those. And we can trace back and see, well, what did those depend on? And in this case, the variable on the left depends on two things that we've already validated are correct. Okay, and we also validate that the variable on the right was correct. And now we see, all right, the error occurred here. It was this input to our later state. And we know its inputs are correct. So we've basically found where is our bug. Our bug is that exact state update is the root cause. Okay, so that was combining the causal technique and the wolf fence technique. We can use, so basically we're trying to be a detective or apply the scientific method. So we're going to inspect our program state and we're going to form hypotheses that about what might be going wrong. Okay, so what does that mean? Well, we might print things. So we might look at what the program prints out. We might add more print statements to get more information. We might use the debugger. So the debugger can be faster if we're going to observe a lot of state than putting in output statements. But they're both doing similar things. So we look at the program state. We hypothesize what might be causing what we're seeing. So maybe we've got a seg fault, and we hypothesize that that could be caused by going out of the bounds of an array of, say, street segments. If that's our hypothesis, what would we expect the behavior to be? So let's see, if our problem is that we're going out of the bounds of, say, a street segments array, then the index variable we're using in some loop should go beyond that array or vector at some point. And then we now know what we're looking for. We have a hypothesis of what might be causing this. We know what behavior that would lead to. Let's perform a controlled experiment to see if our prediction is correct or not. So we could run that scenario in a debugger and actually just watch and see if that's what happens. If it does happen, we found the bug. If it isn't, we have to refine our hypothesis. That was wrong, so we eliminated that as a possibility. That's good. But we now need to come up with another hypothesis. Okay, and generally when you're debugging, you combine all these techniques. So you decide what's the easiest thing to do to get me the most information with the least effort, and you try to do that next. Okay, so to make this kind of more concrete and also show you some of the mechanics of how you can do this on your street map project, we're going to debug the function that we wrote and sped up 2 weeks ago. And for some people, this bled into last week. So over the last 1 to 2 weeks, we wrote this find street segments of intersection function. And we made a fast version of it where we pre-computed a bunch of data in load map. And remember what it's trying to do is you're given an intersection, and we quickly want to return these IDs of the street segments that connect to it. So these 3 IDs are what we'd want to return if we were asked about this intersection. Okay, so remind you of how we coded this. We decided if we want this to be fast, we're just going to pre-compute it. We're going to make a vector for every single intersection, okay? And each of those vectors is actually going to store a subvector. So it's a 2-dimensional vector, basically. And that subvector is the answer. It's the street segments that we need. Okay, so our first vector is indexed by the intersection ID. Okay, goes from 0 to number of intersections minus 1. And every entry in that stores a vector of integers. And those integers are the street segment IDs that we want. And we can just now return them. Okay. So hopefully that is familiar. Let's just review of how this all worked. Okay, so in this entry, intersection 1 would be a vector of the street segment IDs of intersection 1. In this case, it would be 5 street segments. All right, so I'm going to switch screens now, and let's go to this. All right, so let's take a look at. I'm going to switch between command line and NetBeans. You can use either one. Okay, so I just went to libstreetmap source. So that's where my source code is for milestone 1. And I'm just looking at m1.cpp, where Abbott and I have written an implementation for that function. Okay, so we have a global variable, intersection street segments. It's a 2D vector, just like I showed you. And what do? We have a helper function called load intersection street segments. And in load map, we basically load the streets database API. So that's what that does. And after that, we make one call, load intersection street segments. So we call a helper function, which is going to load that global variable. Okay, so what does that look like? This is the code for that. And maybe before I show you that, I'll just show you find street segments of intersection is very simple. All it does is it returns the right entry, intersection street segments, that global variable, the entry for a certain intersection ID. Okay, so it just returns a pre-computed vector of street segments for that intersection. And we know we have the answer because we pre-computed it for every single intersection, and we store, so we store the answer for each one. Okay, so this function that we're trying to write is very simple. It's just returning a pre-computed answer. So the complexity is really in load map. And let me show you a style thing here. So my load map, or our load map, is not really long. It loads the streets database API, and then it calls a helper function to load up that global variable. This is good style, right? We shouldn't have all our code that's doing loading of data structures right inside load map. We should be calling helper functions so it's easier to read. And we did that. We made a helper function that says load intersection street segments. Should have put a comment here. Okay, so this function doesn't have a comment above it. See this right one right now. Loads the global data structure for all intersections, street segs of each. I would probably write a slightly better comment if I wasn't doing this online. Allows fast order one lookup of street segments attached to an intersection. All right, so anyway, I just did that to show a little code style. So you should put that function header in, or that comment for the function in. Okay, now let's look at what this actually does. So remember, it's trying to load that global variable. So the first thing it does is it gets the number of intersections in the whole map. It then makes an empty vector of street segment IDs. It pushes that into the global vector, intersection street segments. So it's pushing this little vector into the first entry of that global vector. And then we go through an intersection by intersection. We say how many street segments are there at this intersection? And then for every street segment at that intersection, we say, give me the ID of the street segment. That's what this SSID is. And then we basically say, okay, let's push that back into the vector of street segments for that intersection. Okay, so we're accessing into our 2D data structure. And so the first dimension, again, is intersection. And for the proper intersection, we're pushing back the street segment ID that we just found. All right, so that's the code. Hopefully that makes sense. Let's try this. So I'm going to do this first from the command line. So I'm just going to make, all right, and there wasn't much to do because I haven't changed much. Actually, I don't think I've saved this. Let me save this. Okay, so I saved this, and now if I make, it'll do more. Okay, the default configuration. Well, what's the default configuration? When I just type make, what do I get? We have a whole bunch of different configurations that we can build. So what's the default one? Yeah, so release is the default. So I just built the release. I'm going to run EC. Oh, and actually I didn't show you something else. Let me show you the rest of this file. So the rest of this file, these are stubbed out functions. So meaning they don't do anything yet. So our close map doesn't properly clean up our data structures. Find street names of intersection just returns an empty vector. Find adjacent intersections returns an empty vector. Okay, so none of the other functions are actually written. They're stubbed out so that they'll compile. So they actually return the right thing, but they all just return a hard-coded empty vector or 0 or something. So none of those other functions are going to pass. The only function I want to pay any attention to its pass-fail status is this find street segments of intersection, because it's the only one that we've written so far. Okay? All right, so I can run EC297 exercise, and I could run all the tests, but there's not all that much point in doing that because I know most of them are going to fail. So I'm just going to ask, what are the testers? And it wants a milestone number, so I forgot the milestone number. Okay, so EC297 exercise has this option -- list testers. And if you forget, all the tools we wrote for this course take a -h. So the -h gives help on the tool. So, okay, that told me that I have all these tests. And the only one I want to run is M1. I'm not going to do performance yet. Let's just do functionality. I want to do the intersection tests because that's actually where the function I care about is tested. Okay, so I want to do run tester. And I'm going to put in, so you put single quote, single quote, and I basically want to do star to match anything, and put another star to match anything, and a third star. So basically, this is going to look for any test that has the word func in it and the word intersection, because those are the ones I want to run. So now I'm going to run that test. Okay, and it tells me it's only going to run one test, so this is going to save me some time. And it didn't go so well. Let me make the screen a bit bigger. It says I failed 3 tests, so I'm going to go look at what exactly happened. Whoops. Okay, so let's scroll up here and take a look at what happened. Oops, there we go. Okay, so this is saying failure. I have a failure in intersection street segments. So intersection street segment is actually the function we've written. That's the one I care about. And it says unhandled exception, test crashed. Okay, then there's a little bit of information saying streets database is already loaded. That's basically from the next test. And then I get a whole bunch of failures, but they're failures in intersection street names, which we haven't written yet. Basically says it expected unknown, but they got empty. It expected unknown again. Well, unknown, but it got empty. So basically my my intersection street names is failing all the tests, but it's because I haven't written it yet. Okay, so that's fine. So actually the failure I care about is this one. Intersection street segments had an unhandled exception and crashed. And that's the one we wrote, so we didn't expect that to happen. All right, and if I go through this, you'll see all these other messages are tests for 2 other functions I haven't written. So there's intersection street names, and then there's a test for find adjacent intersections. Okay, so adjacent intersections, I haven't written that either. So we always get that wrong. We return an empty vector every time. It's fine. We haven't written that yet. So we're not paying any attention to those failures. The only thing we want to pass is that find street segments function, and it didn't pass, but it crashed. So where do I start? Okay, so any ideas? So type them in the chat or unmute. What should we do? We know our test crashed, but that's kind of vague. I could go stare at the code, but maybe you have a better idea. Is there anything I can do that's not going to take me very long that might get me more information? And this is where we're kind of trying to get more information quickly. So what's easy? So we could use the debugger. So that's a good idea. We could use print statements. So yeah, we could go put print statements in. Both good ideas. But I could do something even faster. What can I do really fast? So maybe this isn't obvious. I'm going to go to the line where the error occurred. Well, it didn't tell me that, right? So that would be good, but it actually didn't tell me where the error occurred. It just said the test crashed. So I don't know yet where it occurred, which means I got this whole, I know that it's something to do probably with my load function or my find street segments function, although I'm not even sure about that. Maybe it's a crash somewhere else. So I don't know much. So it hasn't told me the line. Okay, so look at the function where the unhandled exception occurred. Well, let's look at what it actually told me. So that would all be good, but I don't actually have that information yet. Let's go back and look at what it actually told me so far. Okay, let's see. Yeah, so here's my output. Sorry, this is actually tricky to do sometimes on a computer while other people are watching. Okay, so that's my build output. There is my output from the test. Uh, Actually, it did tell me where it crashed. So that's a good idea. Func intersection public CPP 47. Okay. Okay, so yeah, I could go look at this line. This line is actually in the unit tests. So you're right. I could go look at that line in the unit tests. And actually, we'll do that in a minute, okay? So that's a good idea. So remember line 47 of this M1 func intersection test. But the line it's told me about is basically in the unit tests. It's not in my code. It'll tell me what the unit tests were doing, which could be helpful. All right. Actually, let's take a look at that right now. So that is a good idea. So let's see. I'm going to do a vi/cad2/ and I know this path basically. So if I didn't know it, I could just write it down. It told it to me. It's in public. It's in milestones. Okay, so what I can do is if I don't remember what all the options are, I hit Control D. So I hit Control D and it shows me what are all the subdirectories in there, or all the files. So I see M1. I hit Control D again. It shows me what's there. I hit Tab. It'll complete if it can. So it goes to tests. I hit Control D. I can see what's here. M1 func intersection. Okay. Oops. Okay, intersection Toronto. Okay, and I'm hitting Tab to complete because it makes it a lot faster. Okay, it was line 47. So let's go look at what's at line 47. Okay, so line 47, I guess, doesn't help me all that much. All right. It basically says I failed on this test fixture. Test fixture means I'm setting up the test. So it's saying it failed for the intersection street segments when it was setting up the test. Okay, it doesn't actually help me all that much. Okay, but it was a good idea. Go look at the error message. All right, so here's what I'm going to do. So I'm going to type make conf equals debug check. So debug check turns on extra error checking. So I'm going to basically rebuild my program with debug check because that was released before. If I run it in debug check, maybe I'm going to get some additional information. Okay, so, and I can use the up arrow keys to go back to old commands. Okay, so I didn't want to type this long thing again, so just hit the up arrow key till I see this command. I'm going to run it again, and let's see if we get any better information out of this one. So what's the difference between debug check and debugger again? Okay, so debug check is basically built in additional information, additional checking. We turn on checking of do you ever go outside the range of a vector, of an array? Do you access bad memory, and so on? Your program will slow down. Okay, so it's slower than the debug build. So from release, which has optimization, to the debug build, which doesn't, so it makes it easier to run through the debugger and interpret what's going on, you slow down by a factor of usually 3 to 4 times. Debug check turns on all sorts of extra checking, which slows you down by another factor of 7 or so. Okay, so it's slower, but I don't care here. I want to just see what's going on. Okay, and it did give me some more information. So if we looked at this, it says, okay, you're running these intersection tests, and it says that on line 417 of vector, now this is actually the vector class, so I didn't write it, this is in the standard library, but it says that we tried to subscript a container with an out of bounds index. The index that we tried to use was 1, but the container only has 1 element. And for vectors, if you only have 1 element, that is element 0, right? Vectors start at 0. So this actually, now it tells me like the memory address of that object, which doesn't help me all that much. And then we basically get the the message from the unit test saying we halted with an abort, likely clauses, or memory corruption, an assertion or an assertion failure. Okay, so we get the same crash we had before, but before that crash, it told us something useful. We are trying to subscript a container with an index that is too big. It's index 1 and it is not allowed, and that container is a vector. So we have a bunch of extra information. Maybe that's enough for us to figure it out. Gives us a hint. Maybe it's not enough. So let's say that this might give you some ideas, but let's say that it's still not enough. So I'm going to fire up NetBeans, and let's see. I'm in the right directory. Okay, so I'm going to fire up NetBeans. Most of the things I've been doing here, you can do from within NetBeans too. I was just showing you how to do them at the command line. I switch when I'm debugging between the command line and an IDE, depending on what I'm doing, just to basically try to do everything as fast as I can. So some things I find faster to do at a command line. Some things I find faster to do in NetBeans. Okay, so let me get rid of these. And let me make this a bit bigger. Okay. So what I'm going to do now is I want to run the unit tests. All right. And actually I skipped a step. So let me go back to my command prompt. So I want to copy over the unit tests. So EC297 exercise is running some public tests. And if I want to run the debugger on them, I need to copy them into my NetBeans project. So I'm going to go do that right now. So I go to libstreetmap. And let's do an ls. So you see under libstreetmap is source, and in source is basically your code, okay? The code that you've written. In tests are unit tests. So I'm going to go here into tests, and I want to copy over the appropriate unit tests, and this is in the milestone 1 handout. Okay, so it is documented there if you forget this. So, where is this path? So EC290, CAD2, EC297S, public. I don't remember exactly where it is, so I hit Control D. It's going to be milestone 1. I'll hit Control D again. There's a directory called tests. I'll hit Control D again to see what's there. I need 2 things. I need unit test util. Okay, so these are like files that helper functions that are useful. So I'm already in my test directory for my project. So I'm just going to copy it to dot, which means current directory. So I'm copying that file. Okay. And now I hit the up arrow again because I don't want to type everything. I got the right path. And I basically want to get M1 func. Okay. So it's a functional test. It's intersections and it's Toronto. And I'm hitting tab as I type those things in to just fill in. Tab basically fills in the rest of the line. Well, whatever part of the file name is unambiguous, so it can avoid a lot of typing. All right, so I'm going to copy that over. So I've copied over my intersection tests, and and the helper functions. So now what I'm going to do is I can go look at those. So I'm in NetBeans. I'm going to go look at the helper functions aren't super useful. I can look at that, but I'm not going to change them. If I go look at this, this is the file we're crashing on. Remember, we're crashing on line 47. So that message that said where we crashed when we first started this said we crashed on line 47, which is right here. Okay, so I already looked at that. And this is testing intersection street segments. Okay, so it basically makes a bunch of calls to for certain intersections and checks if you give the right answer. So what this means is for the next call, I expect to get these 3 street segments. And then it basically says check that that expected value, the correct value, is the same as what comes back from your function. So if your function is called with intersection 10 and we sort the street segments so they're always in the right order, it should exactly match these 3. Okay, and we didn't even get this far. We actually crashed right there. But that's what this test is. Okay, so that's what this unit test look like. Let me keep going down here. This is testing the intersection street segments. So all good. This is what I care about. Okay, and that's the end of that test. Okay. This next one is for intersection street names. I know that's not going to work. All right, because I haven't actually coded it yet. We just stubbed it out. So I don't want to see the failures from it. I don't want to look at them in the debugger. I'm just going to comment that out. Okay. And let's see, I'm trying to page down here quickly. No, it's not doing it, so that's fine. I'll just use the arrow key then. All right, so there's a whole bunch of stuff here I don't care about. There's another one for JSON intersections. I want to comment that out too. So remember, there were 3 tests in this, and we failed all 3, but 2 of them we haven't coded yet. So I want to get rid of those. I can delete them. I can comment them out. I'm just going to comment them out. Okay. So let's comment that out. All right. So now I basically have this unit test, just has the code for 1 unit test. And what I'm going to do is I want to run the debugger. So I'm going to build the unit tests. Okay. What that does is it builds a different executable. It builds a test libstreetmap executable. It's basically like building ECE 297 exercise. It doesn't build a program that responds to the user. It builds a program that just runs tests. Okay, so what I can do, let's just build debug check first. So I'll show you that you can do this. You can do all this basically inside NetBeans as well. Okay, so I'm building the debug check build. And now I'm going to run. So if I click the green arrow, it means just run. So it's like I ran it from the command line. So I already know what should happen. This should crash. Because I'm running debug check, I should get that better error message. And that's what happens. Okay. It failed, so it crashed. And it basically gave me that same message of I'm trying to subscript some container with an out of bounds index 1, and I know that container is a vector based on the file that I crashed in. So I'm trying to get entry 1 of a vector, and it doesn't exist. Okay, so what do I do next? And I saw this comment earlier. It was basically, well, run the debugger. Whoops. Okay, so I don't want to build the release. So I'm going to run the debugger. My favorite thing to run the debugger on is the debug build. Okay, that's what it's built for. So I select that configuration. I'm selecting unit test debug because I want to run the debugger on the unit tests, not on the executable that I would ship to end customers. All right, so I built that, and let's just run it. Let's see what happens. Okay, so I ran it through the debugger, and let's see, we read this, it says we have a segmentation fault. Segmentation fault, what does segmentation fault mean? So let's type it in the chat if you know what this means. Like, what would have likely caused this? So any ideas? Yeah, accessing out of bounds memory. So I've done something bad to memory. Given the earlier error message, it's probably I'm going outside the bounds of a vector. Okay, so I don't have the rights to access this memory. Okay, I can type one of a few things here. I want to do discard and pause. So remember that left button. It basically says throw away this exception, but I want you to pause the program so I can look at it. Okay, so I click discard and pause, and I can see where did I die. So I died on this green line. Now this green line is way down in the standard library, so I don't recognize it. I didn't write this code. How can I see how I got here? So what should I do to see how I got here?
The call stack?
Yeah, so I click on this. There's this handy call stack button down here at the bottom. So I'm going to click on call stack. And basically the first few lines are deep in the standard library memory allocation. Okay, so I can click here. I can go back to the function that called that last one. Still don't really understand this. That's fine. Okay, this is inside vector. And it's inside... Okay, this is looking a little more familiar. So it's inside vector. That kind of helps me. And it actually is inside pushback. Okay, so I died inside a call to pushback. And I came from this line. Okay, so this is useful. So this is actually saying my load code is the problem. I actually didn't die because maybe I died here, right, in my find street segments of intersection function, but I didn't. Where I died is here in the loading code. And in fact, here, let me get rid of this. That's ignore that. That's a hint. In fact, I died on this line. Okay, so now I know a lot more. I died on that line. I can actually look at the variables still too. So I can look at, if I click on variables, I can see what's going on here. So it tells me that num intersections is big, 150,000, and I'm on intersection 1. So I died pretty early. I can also see that by highlighting variables if I want. Okay, so you can click on the variables window to see things. You can also highlight variables, whoops, and hover over them. So let me just see if I can highlight that properly. And maybe I can't do that when it's just paused like this. But basically, I can tell I died on intersection 1 on this line. And that might be enough information for me to debug this. So I might now know the answer or have a hypothesis, so I might change the code and try fixing it. But let's say I don't know. I still can't quite figure out what's going on. So right now I'm examining a dead program. I cannot single step. I can't move through the program because it's dead. Okay, if I try to single step again, I just go back to this line where the program has already crashed. So I can look at the call stack. I can examine the program state, like look at the variables, but I can't actually watch it run. So maybe I can't figure it out from that. So I'm going to basically do something else. I'm going to set a breakpoint. So I just clicked on this line 55. So I moved my cursor over here and I just left click. If I click again, it'll remove the breakpoint. Okay, click, and I have a breakpoint. Well, I should have a breakpoint. Whoops. It's slower when I'm sharing my screen. Okay, so I'm going to stop the debugger and I'm going to run the debugger again. Does everybody know what a breakpoint is? Do you know what's going to happen when I run the debugger now? Okay, I'm hoping you do. Yeah, it's going to stop there. So I set a breakpoint. I click the run with debugger icon right up here, and it ran and it stopped on this line. Now I can use these little buttons up here. And this one is step over. That's pretty useful. I just want to run this one line at a time, but I don't want to go into the functions because I think I can figure it out just by looking around in this function. So I'm just going to try stepping over. Okay, and if I want to see what's going on in my variables, I can click on this variables window. Okay, so my number of intersections is 150,000. That seems reasonable. Okay, I'm making a vector of street segment IDs, and I just push something into it. So if I want to, I can click on this street segment IDs. Well, actually, I just push that street segment IDs into my intersection. Okay, my num segs at intersection or intersection street segments variable. Okay, and now I'm into this loop, and I'm just going to step through it. Okay, so I'm going to go through this loop. I should go through it 3 times because the number of segments at that intersection is 3. Okay, so this I variable should go 0, 1, 2. That's what I expect. All right, so I go through the first time. I ask, what's my street segment? The street segment ID that comes back, I can see it in the variables window. I can also highlight it. Okay, it's 0. Could be right, seems reasonable. Step over it. So far, everything's going well. I go through this loop a second time, so with I equals 1, and push back into the vector. That seemed to go okay. Step over it, step through it a third time. Street segment ID now is 121,000. Still seems like a reasonable number. Should be that many in Toronto. Push that into the vector. Okay, now I'm done with that intersection. Okay, so I single step again, and you can see my intersection now is intersection 1. All right, so I'm in intersection 1, and this is my problem intersection. I know that this is the one that crashes. So let's see what happens. I go through. The number of street segments at this intersection is 2. That seems okay. And I'm going through, the first one. I go to this line, and I crash. Okay? So I got the same crash I got before. So it is happening with intersection 1. It happens when I try to put the first street segment in there. All right, so I can discard and pause this again. Okay, so I want to try again. I'm going to hit stop the debugger. I'm just going to run again through the debugger. My breakpoint's still there, so it stops there. I know where my error is, so I'm just going to put a breakpoint on it because I can now go faster. I don't need to single step. I want to get back to right where the error occurs. So I can hit this little green button to continue. So it's going to go to the next breakpoint. So basically, let me bring down the variables so I can see what's going on. Right now, I'm on intersection 0 again, and I want to get to intersection 1. So I'm going to hit continue, and basically, I'm going through that second loop. You can see I is now 2. Okay, so if I highlight this, you can see it in the variables window, but you can also highlight it here. I equals 2. Let's go through again. All right, I'm now on intersection 1. And I can add extra things to look at. If I go over here, well, even here is easier. So you see it, enter new watch. I can actually type things in here that I want to see. The variables window shows me variables that the debugger thinks I might be interested in, but I can type more things. So I'm going to type, I want to see intersection street segments dot size. Okay. And let's see if I don't think I spelled that correctly. Let's see if I spelled this correctly. Intersection street segments dot size. Okay, so I want to see what the size of this vector is. And it's actually 1. So there is only one entry in there. And I'm about to access entry 1. But if the size is only 1, then there only is a 0th entry. So this is my bug. I cannot access intersection 1, and I'm about to do it. If I continue, it's going to crash. All right, so it crashed. Okay, so hopefully that made sense to people. Do you understand how we found that bug? And now what do we do to fix it? So I've asked 2 questions. So do you understand the procedure? Okay, so I'm going to discard and pause this. I'm going to shut the debugger down. Okay. It's best to always stop the debugger when you're done because NetBeans will leave lots of them lying around and get slow. And it's also one other gotcha is NetBeans appears to have a bug if you type a watch, so something like the let's see, let me run the debugger again so I can show you the watches I put in. Okay, so we'll tell you one gotcha that we found with NetBeans. You can enter watch points here and they'll live on until you delete them. So I'm going to delete that one. If I type a watch point and it's a variable that goes out of scope, it seems to give NetBeans some problems. So it shouldn't, but basically it means when you enter a watch here, you can type anything you want and look at it. But if that variable is going to go out of scope, then it's probably best to just delete the watch because NetBeans seems to have trouble with that. Yeah, so I can see someone has already, so G has commented on how to fix this. So the problem is you can't use this subscript operator on a vector to create elements. You can only use it to access elements that you've already created. And I haven't done that, right? I actually only pushed back one thing into my intersection street segments vector, so it only has one thing in it. Now I can fix this code by, I know how many things I should have, and there's a handy function for that. So I can basically say intersection street segments dot resize, and I tell it, this basically immediately creates, it makes the vector have that size, and all the entries will be constructed with the default constructor. Okay, so for a 2-dimensional vector like this, it means it creates an empty vector in every single index, and all the indexes become valid. So our size immediately will become num intersections if I do this with num intersections. And that's a convenient way to code this. I basically have made the first vector, the first dimension of my vector exactly the right size, and the second dimension is now every entry is initialized to an empty vector. If I do that, I can now actually use this square bracket operator to access things. So let's try stopping this debugger. Let's try rebuilding. Okay, and where did my build buttons go? Should rebuild it when I click on this anyway. Yeah. So, okay, so it built it, it ran, and I'm going to clear my breakpoints so that it just runs all the way through, and we'll see what happens. Okay, so I just clicked on the left bar to get rid of the breakpoints, and I think I got rid of them. Maybe I didn't get rid of that one. Okay, let's click here again to get rid of that breakpoint, and let's just keep going. All right, and to see at the end here, this output says 2 tests passed. So that's good. So we actually fixed the function, and it works now. And the fix is actually less tricky, in a big program than finding the original flaw. Let's just try that from the command line. Okay, so if I run, see, I want to run that same EC297 exercise command. So it should do the same thing. I just ran my unit tests that I copied over. They passed, so I expect exercise to pass, but let's check. Let's be sure. Does anybody know what this syntax is doing? So I just put an exclamation mark and then a few characters. The first part of EC297 exercise. Have you guys seen that notation before? It's just a convenience for shell commands. It basically means find the first command that I've typed in this session that matches those characters. Okay, so I do that, and it fills in, oops, I'm in the wrong directory, so I'm going to go back up. Okay, so I need to run this from where my mapper is. So I can use the up arrow buttons to find an old command. I just did that. But I can also do this. I can say, I know I typed EC297 exercise with all the right options before. Just go find the first command that matches those characters and run it. And let's see, still doesn't exist. Oh yeah, so I was building the unit test. I haven't actually built the regular program for a little while. So I'm gonna do another make to make sure I've got the library that exercise needs built. So if it says I can't find the library to run, just build again. And that's because in NetBeans, I was only building the unit test executable. And now I want to run my EC297 exercise again. So let's do that. And again, I'm just using that bang notation to save typing. So using the up and down arrow keys and using that bang notation, the exclamation mark's called bang, can just save you a lot of typing. Okay, so 2 of 3 tests failed, which is actually good, because remember, we haven't coded 2 of the 3 tests. For intersections, we've only written 1 of these tests. So if I go back up and look at what happened here, let's see what happened. Basically, there's no output until we get a failure in intersection street names. The convention for unit tests is if they pass, they don't say anything. So they pass silently, they fail noisily. So this actually means that the function we've written now passes as tests. The next 2 don't because we haven't written them yet, but we've moved forward. And that is it for how you debug this. So if you follow these steps of copy over the right unit tests, you can run them in the debugger. You also saw that building debug check is very quick and often gives you some insight into what's going wrong. So I usually do that even before I run the debugger. I just build debug check, run it, see if it gives me some insight. If I can find and fix it, great. If not, okay, let's look at the code. Let's bring up the debugger, go to the next step. Any questions on anything we went through here? Okay.
I have a
Yeah.
So the solution was to resize, which I understand why, but I was just wondering, there's another member function called insert, and I know that you have to give it a location to insert at, but the location is not using the square brackets. So
Yeah.
could you have just used dot insert and then give that vector's end, because
Yes.
there's also
You're right. You could do that. So I could do insert. I could basically build up each of the street segment ID vectors and then insert them at the right spot in my intersection street segment vector, and that would work too. So that would also be fine. Does that make sense?
Okay, yeah, thanks.
I could also code the whole thing to be done with pushback, but the code is basically just a little more inconvenient. If you look at this, you'll see that I only push back once to intersection street segments, like the first dimension of the vector, which isn't enough. If I push back, 150,000 times, that would actually make the vector big enough. But it's kind of inconvenient versus just calling resize. And you're right, the insert would also work. So there's multiple ways to fix this, but basically the code we had is not going to do it. We can't use the square bracket operator to create things, and we didn't properly create the first dimension of the vector. Is there a point to running the exercises for performance tests? Yeah, so you should run so basically I ran this just for functionality. I could run it for performance, and in fact, this will pass performance as well, because, well, let's see if I can do that right now. I haven't actually done that. Let's see. If I change this from func to perf, okay, now it's going to run anything that has both perf and intersection, and it should pass one of the tests. It's going to fail the ones that I haven't actually coded. But this one should now pass the performance tests. And that's exactly what happens. So 2 of the 3 tests fail. Those are the 2 that we haven't actually written. The one that we did write now passes the performance tests. And the last build I did was release, because that's the default. So that's the right way to test the performance. I see some of your functions just have an if statement and return are considered too slow. That shouldn't happen. I mean, so you can post on Piazza with a private post if you want, but once you get the right data structure, and then and you just return that data, that's about as fast as you can go. If you're using the wrong data structure, then even just the return something from this data structure, if it's a slow data structure to go get the data from, then that might be too slow. So I guess basically I would post that on Piazza or ask your TA if you've got something where you go, I really just can't figure this out. Are there more performance tests or just functional tests? There are more functional tests than performance, because there are some functions that we test to make sure they work, but we don't test their performance. All things that we test performance of, we also have a functional test. Yeah, so Mark, I guess if you have error checks that are slow, you could try commenting them out just to see if that makes you pass. That shouldn't be it. So my guess is it's the data structure or something else. If you really can't figure it out, I would basically go and make a private post on Piazza. You can put your actual code in and your actual run. Also, make sure you're running on an unloaded machine with the release build. Unloaded meaning you can type this command. So if I type top, I can see who's running on this machine. So what's running here right now? There are a few other people on here, but the percent CPU is low. Nobody's doing anything really intense, because I can see it's only like 10% CPU for somebody. So it shouldn't slow me down too much, and I did pass the performance tests. If you see some 100s here, it means somebody's just running flat out on one of your CPUs, and that can start slowing you down. Okay? Any other questions on that? Maybe I'll just quickly bring this up. We don't have time to go through it, but in case you want a further debugging exercise, let's see if I can get back to this. All right. There. Okay. So there's a team debugging activity in here where you can basically go to an online IDE, and we've given you a little program that takes some arguments from the command line. So by doing this, you'll learn how do arguments come in from the command line to a program, and it sorts its arguments, except it doesn't really work. Okay, so it actually doesn't sort. It's supposed to sort its input arguments. So if you basically typed argsort, which is the name of the program, 6, 1, and 3, it should print out 1, 3, 6. It's just supposed to sort its inputs, but it doesn't actually work. So the idea is you apply the different techniques we talked about, this infection model, wolf fences, and this detective or scientific method to debug it. So if you click on that, you'll basically get a little online IDE that allows you to run the debugger and compile. And you have to hit the fork button before you can actually make any edits. But yeah, you can take a crack at that. And you don't need, the key point here is you don't need to understand, let me show you the code, because I think I have that up. Yeah, maybe not. Okay. The key point in this one, you click on it, you'll see something like this. Okay, so you'll see the code and you'll see a little online IDE. And the first time you go here, you should see a fork button. You hit the fork button and now you've got your own private copy of the code and you can compile and run and debug. You can see there's a kind of nasty looking sorting routine, and there's a main program, like a main function. You want to think about, well, what is the most productive way to debug this? It is not to go read all the code and try to fully understand it. You instead want to think about these techniques that we talked about and go, well, which of these is going to be kind of the most productive? What should I start with? Okay. But anyway, I won't do that right now because I'll leave that to you if you want to go off and try that. But yeah, there are ways to debug a program like that where you never actually learn all the code by using these techniques. And that gets more and more important as programs get bigger because you just can't go read all the code. It takes too long. All right, so with that, I'm going to stop this recording. And I think Abid or I is going to repeat this for anyone who's joined.